This tutorial is about setting up Internet of Things labs for software engineers, for software developers, for system integration activities. At least if it's not for the training, it could be used also as a showroom for the people managing our cities. This IoT lab is very much specialized and focused on Internet of Things for smart cities. What we will see here is how to set up the lab. Our labs, we have this experience from setting up 10 IoT labs overall Egypt in different governorates. We're targeting postgraduate students, we're targeting undergraduate students as well. We're targeting professionals working in software development companies who would like to learn how to develop IoT applications for smart cities. Our labs, as we will see it, consists of 3 levels. One is very basic level for an IoT lab, what should be there. The second level is much more advanced, targeting more professionals. The third level is actually focusing on a very specific domain for self-driving cars. Okay. There seems to be something with the, how do we rotate? Can somebody from the IT help me, please? Yeah. I'm not able to move to the next slide, so until we have someone from the IT to help us move between the slides. As I said, the lab consists of 3 levels. Very quickly about our company. Our company is called Spine Sense Labs. It's an Egyptian company. Set it up since end of 2013. We started this after the Egyptian Revolution, 2 years after the Egyptian Revolution. It was a very tough time to start a business, but it worked out. We had a journey that's full of milestones. The first milestone we had in 2014, where we had a reward from Cairo Innovate event. That was an innovation event competing and demonstrating different innovations from software and high-tech companies. In 2015, we became the best platform from Sigfox perspective. Sigfox is a wireless IoT technology operator. They operate in different countries. They are now present in 70 countries worldwide. We had this partnership with Sigfox back in 2014, and 1 year later we became the best platform among other 16 platforms that existed at this point of time for Internet of Things. By 2016, we've been requested to join into M Alliance. We've been very happy to receive this request because it came from the Alliance itself. The Alliance is headquartered in Germany. They requested us to become a member of the Alliance, and they even modified the Alliance policy to include our company in the Alliance. Also in 2016, we won one of the very tough competitions. It is called MIT Enterprise Forum. This is a competition for startups, NGO projects, high-tech companies. The competition applicants are 12,000 applications from worldwide. They have been shortlisted to 38 applicants. So we had 2 positions in the 38. As a top 38 out of 12,000. This is a very tough competition. So once you apply, you wait for being shortlisted after 6 months because it's 12,000 competitors competing with you. We've also been shortlisted at the 9 top. Yeah. Can you hear me from this small mic here?
Yeah.
Okay. Great. So we've been shortlisted at the top 9 as well, and then The event was sponsored by media companies, so they very much focused for the top 3 to be those who are serving the TV media. So all the high-tech guys out of the TV media didn't win that competition. In 2017, we got the Best Technology Enterprise over Egypt. In 2019, we started to appear in international market research reports. The first one was IDC report on precision agriculture, smart agriculture solutions, the top 30 innovative smart agriculture solutions worldwide. Let's jump in 2021. By 2021, we started to appear on the best IoT platforms worldwide by MashNation. MashNation is an American-Canadian company. They focus on IoT platforms, testing, verification, and the use cases, how beneficial it is. It is a consulting company that serves its customers to select the best platforms that suit the customer needs. So they have they publish an annual report on IoT application enablement platforms. And in 2021, we've been shortlisted among 13 platforms worldwide. In 2022, we also been shortlisted in the report, but I don't have the link here. So the link in 2021 report, this is the free version of the report. It's a summary version of the report. It is almost 20 pages. The details are more than 150 pages, but this is a paid version. You have to pay for it, but you can access the summary version for free. In 2021, we've also been selected by Orange, Egypt, as the IoT platform provider for enterprise and corporate customers for Orange. Those who would like to work in smart city solutions, solutions for compounds, for gated communities, for smart universities, university campus, shopping malls, transportation management. That's what we do with Orange Egypt. Also in 2021, we have reached 10 IoT labs. These IoT labs are all financed by Ministry of Communication and Information Technology. They are spread over 10 governorates. We have the first lab was in a smart village. It was sponsored by Ministry of Communication and Academy of Scientific Research. The rest of the 9 other labs are all sponsored by Ministry of Communication upon the success of the first one. We have one in Smart Village, one in Menufeya Governorate, in Shibin, one in Mansoura, one in Minya, one in Asyut, one in Aswan, one in Suhag, one in Ina. Now we also have one in Alexandria and one in Port Said. These labs has lots of IoT devices and lots of wireless technologies, wireless technology gateways, and the live showcases of street lighting, parking management, waste management, with tutorials and curriculum how to do these applications, how to start it from a commercial device and you build the software, or if you're going to develop the prototype for the device itself. We will also we will go through the lab details. The session is all about the lab, but I'm just giving you an overview. The company behind these labs, what does this company do, where the company background is coming from, so you can estimate or predict and evaluate the content of the lab. In 2021, we also worked with Upper Egypt Development Agency. That's a governmental organization very much focused on Upper Egypt cities to actually improve the living in the city, improve the economics of these cities in Upper Egypt. So we worked with them on a project for smart transportation. So we're changing the traditional transportation stations from the classical way of being crowded, being messy areas, into being very much organized, timely scaled. You can also see if there are buses available for you in the station now or not. All are remotely. We can see 10 IoT use cases in each of those smart stations. Now let's move to the focus of the session, which is the IoT labs. Usually IoT solutions are serving 5 main categories. One category is the home consumer area. That's a very wide area with lots of devices in the home consumer. For the home consumer, the focus usually from a consumer point of view is the IoT devices itself. And consumers evaluate and validate having the device in their hands. So they can see, so they very much concentrate on the device and the device capabilities. They pay for having the device. Our IoT lab is not covering the home consumer area. On the other side, there is also very rich area, which is smart cities. These are usually serving the city itself, the living inside the city. Usually the main customers here are the municipalities running the cities itself. So here you can see street lighting solutions that are very much focused on reducing the cost of turning your light on and off during the midnights. Parking management, waste management, transportation management, utilities, everything that is considered to serve everyone living in the city. Not selected people at home, but this is global solutions overall as a whole city. The focus here is on the devices, is on the communication technologies, is on the use cases and the benefits that will serve the city, the benefits that the municipality running the city will get, which is either a cost reduction or operational excellence, doing things in a better way, saving time, saving cost for the municipality running the city itself. The other 3 pillars are building management. These are coming from the building management solutions or BMS solutions. At a point of time will turn to be IoT based solutions as well. Transport and mobility it's a very famous pillar. This includes self-driving cars. Yes, these are the famous ones, the autonomous ones, but there is also non-self-driving but connected for preventive maintenance solutions. And in the middle we have the health and body management pillar. Those are the 5 main pillars for IoT solutions. Our IoT labs are very much focused on the cities and partially the buildings. Now let's see what these labs would be serving for. These labs are supposed to serve the future jobs. Why the labs are important? Because these are the future opportunities that youth can find now. So there is a formula here behind the number of jobs that could be available in the future depending on or relying on IoT solutions. It is expected to be 125 million software-related jobs specifically created due to IoT, and this is in 2025. These are inputs from IDC market research. Okay, so if we go now deeply into the content of the lab, what should an IoT lab have? To be able to provide the content for the lab, we should think first of what are the components required for an IoT solution. An IoT solution would consist of some IoT devices. Those could be home devices like a refrigerator or a lamp at home, or it could be a utility meter, it could be smartwatches, or it could be other sensors like parking sensors in the street, temperature, humidity sensors inside the building, and so on. So this would be the first point or the first component of an IoT solution. It doesn't work alone. These devices should be connected to the internet. That's why it is called Internet of Things. So the next component would be the connectivity, to connect these devices to the internet. And these connectivity are actually, there are different options, different scenarios for the connectivity. We are all very famous, the very famous 4G and 5G are 2 of the connectivity options. There could be other connectivity options. The most famous ones now are Things Network or LoRaWAN, Bluetooth Low Energy, and the traditional LoRa. Those connectivity options are really numerous. We stopped counting how many connectivity options do we have now. The idea here for the connectivity is to save power for the devices. So these IoT devices are actually battery operated devices. Most of them are battery operated, and the better the wireless communication, it would be considered a better wireless communication if it saves the battery power for the device, and at the same time can transmit as much data as possible to a longer distance as possible. So the longer distance you can transmit with less battery power, the better the wireless technology. So these are the two main components. For the wireless technologies to work to transmit data from the devices, usually it transmits the data to another point that's a little bit far from that. To understand why do we need wireless communication, let's look at the top level of the slide. This is what we all very familiar with, the mobile applications. While you are sitting at home, you're using your mobile phone to chat over WhatsApp with someone else remotely somewhere in the world. And you do this by connecting your mobile phone to a Wi-Fi network at your home. The Wi-Fi network is very similar to these connectivity options for Internet of Things. And at your home, your Wi-Fi network is working because you have what's called Wi-Fi router or ADSL router or Wi-Fi gateway at home. Similarly, we have IoT gateways that should be available in the buildings or in the streets or in the surroundings of your IoT device. Once your data moves from, now I'm comparing the mobile applications to the IoT devices. So if you're sending WhatsApp message from your mobile phone, it goes out from your mobile through the Wi-Fi network, it reaches your Wi-Fi gateway at home, or Wi-Fi router or ADSL router. These are all the same names for the same thing. Once it reaches the router, it needs to be transmitted to much longer distances, and usually this happens over 3G network, 4G networks, or fiber cables, or usually long distance data transmission over fiber or over Ethernet cables or transmission lines like long distance phone lines. The data is transmitted, again, if we're talking about the mobile phone, then the data is transmitted from your WhatsApp, reaching WhatsApp servers over the cloud. The same thing happens here over Internet of Things. So data goes out from the IoT devices over one of those wireless technologies through a gateway, and it goes through a carrier network as well. The carrier network could be, again, fiber, 2G, 3G, 4G, but we can see also other options for Internet of Things. That's why we have Sigfox here. This is the company that I mentioned at the beginning. This is a wireless network operator working in 70 countries worldwide now. There could be another option like satellite communication if you are outside the cities. So if you're in the desert or if you are in the sea or in the ocean, so your only connectivity option available there is a satellite communication. So data goes out from the devices, passing through this path, and it reaches a server somewhere on the cloud. These servers on the cloud are the application enablement platform, and one of them is our platform. That's what we call it, Master of Things. Once you reach the platform, you start building the applications on top of the platform. The applications usually serve in one of the 5 main pillars, and as we said, we are very much focused for the IoT labs on the smart cities. Okay, so if these are the most important components of an IoT solution, then these components should be reflected in the IoT labs for the learners or the students making use of this lab to be able to understand every component and play with the alternatives of each component. Each component of those have multiple alternatives that you can use. So we should have all these components in the labs, and as much as we can, with different alternatives for each component. Having said so, we looked at the lab as 3 levels of building an IoT lab. The basic level is actually your mobile phone and what we call IoT Innovation Kit. That's a hardware, a handy hardware that has 17 sensors and actuators built inside this device. So you can use it to innovate new use cases. And this, we call it Mobile IoT Lab because it's very handy. You can have it. This becomes your own lab. You can buy your own IoT kit, and with your own mobile phone, you take it at home, and you use it at home. You use it in events like this one, or seminars for education purpose, even in school. And this becomes very good because it is also attached with an online learning courses, how to use these devices to build IoT applications. So if we said an IoT lab should have 6 components, and now we're looking at only one, which is the device, where is the rest of the 5 components? In this version of the lab, you have the device, and you have the connectivity here, which is your 2G, 3G, 4G network. You have the Bluetooth and Wi-Fi here as well. So you have the second component, which is the communication part. For this data to be valuable, you need to build an application, and hence there's an IoT application enablement platform that is available on the cloud to serve you with those very small devices. So this very small version of the lab, which is the IoT Innovation Kit with your mobile phone, it comes with online learning courses plus cloud service for IoT application enabled platform. The second level of the lab, we call it the Expert IoT Lab. This is where we have different types of devices that serves different solutions in the cities: parking, waste management, transportation management, street lighting, and so on. And in this version, we don't just have innovation kits like this one, but we also have the gateways, different types of gateways. Gateways for Bluetooth Low Energy, gateways for LoRaWAN, gateways for LoRa, and so on. Additionally, we also have commercial version of the devices. So you can see the actual commercial version of a parking sensor from different vendors available in the lab. You can see the street lighting with street lighting controllers, the actual versions that companies are selling it for the municipalities. Additionally, you have a learning maquette. That's a small city maquette with street lighting, parking, waste management, transportation, water level, and irrigation management, all on a learning level. This maquette is 130 meters width by 180, 100.8 meters by 100 by 1.3 meters, 1.3 by 108 by 1.8 meters. So it looks like a very small city. You play with it, you manage the whole city, and it comes also with a curriculum how to build these solutions. The curriculum is, part of it is published online, but part of it is also in a class-based training where you have an instructor to teach you how to develop these solutions. Again, this comes with a version of the IoT application enablement platform and sample applications with its source code provided, so for students to be able to learn and to practice and to play with these applications. It's not just the maquette. As I said, the actual live versions of these solutions are also provided inside the lab. This is why this expert lab should be in a place, in a ground floor, with large windows to be able to see what's happening in the outside of the lab, where we install smart pools outside, where we install irrigation management system in the outside, where we install parking sensors in the outside of the lab. So you're sitting inside the lab, yes, but you can also see from the window of the lab what's happening outside, and you can control these IoT solutions in the surroundings of the lab through web interfaces, web applications available inside the lab, where the students build it by themselves, interact with it by themselves. That's level 2 of the lab. We will go in details for each one. Level 3, where we are focused on the self-driving technologies and satellite communication. These are much more advanced type of solutions that requires much more technical capabilities, where we provide low-speed self-driving cars, 2 cars for each lab, and these cars are moving around the lab itself, in the streets, inside a gated community that hosts the lab. This is supposed to be inside universities, inside educational institutions. Okay, so let's look at level 1. In level 1, we have the mobile phone with a mobile application available on the marketplace, available on the Android marketplace. This mobile application actually turns your mobile phone into an IoT device. Why? Because your smartphone is full of sensors and actuators, and usually you cannot control these sensors and actuators by yourself. It is the applications that make use of these sensors, or the phone itself utilizes these sensors that are built inside the phone. So this mobile application, we call it Master of Things IoT Kit. It actually gives you control over all your sensors, all the sensors in your phone, and all the actuators in your phone. For example, some of the sensors you can see here is a proximity sensor. Usually, every smartphone has a proximity sensor. If you put it on your face, it turns off the screen of the phone. This proximity sensor, you can use it and you can measure the values for it using this mobile application, and so on. So every phone, smartphones usually have somewhere between 5 sensors up to 20 sensors. How advanced is your phone? This mobile application will give you access to most of these sensors and actuators in your phone. Using this mobile application, you're actually turning your mobile phone into an IoT device that you can control remotely and measure its status remotely. The beauty about this application, it allows your trainees, if they are sitting at home, they don't come to your lab, they can use their mobile phone while sitting anywhere with the online courses and with the cloud-based platform to develop the applications in a very small, handy, and cheap IoT device that is provided totally for free for end users to use. In this version of level 1 of the IoT lab, we also provide the IoT kit to take you from the feeling that this is a mobile phone. No, it is not. Once you're having your mobile phone, you're very much familiar with the phone, you feel this is a phone. It's not an IoT device. So we'll take you from feeling it is a mobile phone into getting it in an actual IoT device with much more sensors and much more actuators and use cases. Okay, for the online courses, it is available on maharatech.gov.eg. This is an online learning portal that is developed by the Ministry of Information and Communication Technology. It teaches different programming languages. It teaches different high-tech background technologies. And one of those is the Internet of Things courses. We're doing this with the Ministry of Information Technology. And we have 2 published courses now, and we are working on 3 more courses. So this becomes a curriculum for those who would like to develop IoT applications from ABC to XYZ, being an advanced application developer. In these 2 courses, we're teaching them the value chain, the components in the value chain, the value of each component, the alternatives of each component, what type of alternatives is suitable for which use cases. So, for example, we talk about Sigfox, when to use Sigfox, and when not to use Sigfox, when to use LoRaWAN and when not. LoRaWAN is not suitable. Bluetooth, when it is good for, which use cases that it can be used for, the benefits of using Bluetooth Low Energy versus when not to go for Bluetooth Low Energy, and so on. So we take them from the concepts even to the details of the wireless technologies. In the second course, available online in this learning portal as well, these online courses are provided totally for free for those using this version of the IoT lab. Great. I'm happy that we have some of the audience who attended the courses as well. So By the end of those 2 courses, you can also get your own certification, which is a reward of recognition for yourself that you can use to publish on social media, put it on your LinkedIn profile, so people can now see that you have learned this skill and they can now knock your doors asking your help to develop applications. So we're now putting you in the first step of your future career for developing IoT solutions. If we look into details of the mobile IoT application, once you run the application, you install it on your phone, you will notice that it displays all the sensors of your phone. It tells you have an accelerometer in this phone, you have a battery sensor. All the phones has battery sensor. Some of the phones has light intensity sensors. All the phones has GPS. All the phones has signal strength sensors that measures the quality of the network signals. All the phones has touch screens, so now you can play with the touch screen and its sensors in your phone. Some phones has speedometers. Most of the phones has proximity. As we said, once you put the phone on your face, it turns off the screen. This is due to having a proximity in your phone. So you can now play with the proximity and see how much does it measure. It measures the distance between the phone and something else. Some phones has pressure sensors. Most of the phones every phone has a mic, so you can now also measure the sensitivity of the noise level around you, the sound level around your environment. Some phones has magnetic field sensors. Some phones has gyroscopes and orientation. Advanced phones has NFC readers. We will talk about this later. All the phones has Bluetooth. All the phones has, once you have a Bluetooth in your phone, you can also use it as a scanner and the Bluetooth scanners. So we give you access to all the sensors in your phone. If one of the sensors are not available, you will notice that this icon for a temperature sensor, it has a red mark here. It means that your phone doesn't have this sensor and you cannot measure the temperature because your phone is limited in its capabilities compared to another sensors that you have, like the proximity. This one is available. So we now teach you how to turn on the sensors, how to measure the values of these sensors and use it to transmit its value to the cloud. So we take you in a step-by-step what type of sensors we are including in this mobile application. We're talking about 17 sensors and I think 5 actuators. So in total we have 22 sensors, actuators, elements in the phone that are accessible with this mobile application. And during the online courses, you can play with these and start activating it, sending its data out to the cloud. Compared to the actual IoT kit device that you can also have, which also have almost 17 sensors plus actuators. This one has much more touch buttons. It has color LEDs, so it can emit color lights, different color lights here. It comes also with a DC motor that you can control. It comes with a servo motor that you can control. You can find more information about this device in facebook.com/iotechinnovate. That's the page that will give you more information about the IoTech device. It has current sensors, so you can measure the current passing in a wire, electricity wire at your home. It has two power relays, so you can control lighting at home or control the lighting in a pool. We will see this in the examples. It has also 4 external connectors for temperature, humidity sensors that comes with the IoTech device. Another plug for the proximity, another plug for IR, one for the water level as well. Okay, so now what we have seen here is the IoT devices. Would it be a phone or the IoTech? This is the first component. Because we have Bluetooth, we have Wi-Fi, we have 2G, 3G in these devices, then we also have the communication. Then we move to the next step, which is the IoT Application Enablement Platform. So in this lab, we also offer a cloud-based version of Master of Things, which is available over the link training.masteroftthings.com or learning.masteroftthings.com. If you go for this and subscribe, you get an account that's free for lifetime for individual use. So you don't use it for commercial solutions, but you can use it for learning, teaching, and training. Once you log in to this account, you would be tagged as a developer, and you get access to a development environment that's in a drag and drop way you can build your application. So this is a low-code development solution. It comes with a set of plugins. Some of the plugins are used for data visualizations, like charts, different types of charts, maps, different types of maps, tabular forms. Some of the plugins can help you to build web interfaces, web forms to take input from your users. So you have text boxes, text areas, check boxes, drop, and so on. Some of the plugins are timer-based, so it can help you to do things that can change by time. So you can fire some events after 1 minute or a few seconds. A plugin that can help you to connect to external web services, to other systems. A very, I would say, very interactive set of plugins that can help you build complete web applications. The idea is that you design your page here, you drag a line chart, for example, you put it here, you play with the size and colors of a chart in the plugin properties here, and the most important property is what data would be displayed in this chart. Now, if you have your mobile phone, which has a temperature sensor, or if you have the IoT, which has a temperature sensor, and you would like to display the temperature value in your city location versus the time. How to do this? You put a line chart, and then you go for the data source. When you click on the data source, you get a list of devices that's connected to the platform and your account have access to. So if you connect your mobile phone, you get all the sensors of your phone listed here, and it's only you who can see these data coming from your own mobile phone. You select which sensor. If you'd like to put the weather and temperature of the locations, then you select the weather sensor. This is how you named the sensor in your phone. You called it a weather sensor. And the platform tells you this weather sensor is actually collecting data about the current temperature, the current pressure, and the minimum temperature during the last hour, the maximum temperature during the last hour. So what would you like to display here? If you right-click on this, you can also get some of the aggregate functions, so you can have minimum, maximum, sum, and so on. Until now, you have not written any line of code. It's totally drag and drop and with some selections. And how many readings you would like to display out of this sensor over the time. So the guy who have been doing this example has wanted to show the last 100 readings out of the temperature, and he wanted to show it in a versus the time, and you can also select different time formats. Now, if you've done so, this chart will display the temperature over the time. So you can also give it a name, and you build your web page that will display this temperature. You can build as much as you like of the pages, so your complete web application is actually one project with different pages. So this becomes your own project that you can later on sell or give to your customer. Once you start by learning, and now you have your certification, and you publish that over the internet, over LinkedIn, then people will come to you to start buying these services from you. Okay, that's the platform. The platform has lots of capabilities. We will not be able to go through it all here, but just to show you quickly that there's also professional level of the platform here, that from a city perspective, you don't expect the people installing the smart poles in the streets, or the parking sensors in the streets, or the weather stations in the city to install just one device. If you're going to install parking sensors, this would be thousands of devices in every city. So how they will install every sensor and give it a name and put its location? No. There is a way here to import bulk number of sensors, export number of sensors, exchange these sensors between the cities and the installation teams. In this interface as well, you can monitor the events. So you can monitor the temperature. If it goes to a certain level, you can take an action, which we call it event here. So you may, one of the events is sending an email. Another event could be calling a mobile number. Another event could be connecting to another system to send the data to another web service. So this one comes with 16 built-in events, from email to alert on a GUI to voice call, SMS, and so on. Let's move from the capabilities of the platform. In a city scale, not on a lab, you will need to install hundreds of devices. This is why you can add one new sensor, or you can import bulk of thousands of sensors once inside the platform. You can deal with the sensor, what we call sensor profile definitions, the settings of the sensor and the profile of the sensor, as if you're dealing with a file. So you can copy and paste it. You can, some of the sensors, you will be able to edit its properties or delete its definitions, because your administrator, who is administrating this version of the platform, has given you this privilege, while other sensors, you can only view its settings because you don't have the privilege to work with that. We use this in the lab, so you can see the predefined set of sensors inside the lab are available for you. You can copy them, and once you copy it, you get your own copy, you edit it, you delete it, you replicate it, whatever you do, but the original version of the definitions for the devices inside the lab remains as it is. Okay. What you need to define, or what you can define about each sensor. Each sensor profile contains multiple parameters, but you only need to define the minimal number of parameters, which is a name for the sensor, a unique identifier for the sensor, a driver ID and driver password. Those are the ones that you should put. The rest is optional. The more you will put, the better. So if you define a sensor, in a parking sensor in the street, you can also define where this parking sensor is installed geographically on a latitude and longitude. Once you put a temperature sensor, you can say, okay, this temperature sensor is located in an area called Long Beach, things like that. But the minimal is what is required. Okay, the platform comes with an administration interface for the person sitting in the lab to administrate the capabilities of the people working with this lab, working with these devices. What they can do, he can divide the users inside the lab or the visitors for this lab, defines the users, gives them usernames and passwords, groups them into groups, and then give this group access to specific sensors, specific sensor profiles, specific project pages of those provided with the lab with the sample source code so they can see it, or gives them access to edit this source code, replicate it, and play with its source code. The administrator can either start by a group of users and give them access, or start from a sensor and see who has access to this sensor from before, from previous sessions, or who have access till now while he should be removed. He can also start with the applications or the project management and see who has access or provide an additional access to that. Okay, now let's consider what is really physically inside the lab that serves the cities. We talked about different types of wireless communication. So we have multiple gateways, one gateway for each of those. So we have few Bluetooth low energy gateways. We have few LoRaWAN gateways, from two different types of vendors. This one is a French company called Kerlink. This one is a Netherlands-based company. It's called TTN, the most famous LoRaWAN guys. This Bluetooth Low Energy is coming from a Chinese company. So now I'm trying to tell you that every component in the lab here is coming from a different country. So this becomes really a rich mix and varieties of components, but it's also a burden on the persons that's setting up this lab to purchase all of those imported from different locations. That's why it is very good to buy it from one who can really collect all of those and send them to you in one batch. So you don't go and the customs for each component of those ones. So in these IoT labs, we have 35 different components coming from 35 different countries. And each component, we have multiple of it to be able to serve multiple students. So we designed these labs to be able to serve at least 15 concurrent students at the same time. So for example, in the IoTech, you can find 20 IoTech inside the lab, 15 that would be in the hands of the trainees inside the lab, one with the instructor, two running a smart city maquette, and one that is spare in case one goes faulty. These are, we talked about the gateways, so now let's consider the innovation kits. So these different types of innovation kits, it is targeting the software developers, not the embedded systems guys or not the hardware maker guys. These innovation kits are meant to be used by software developers who are maybe coming from a web development background and they don't have the embedded systems knowledge. So you just configure it in a way or another. So this IoTech is very much configurable using your mobile phone with a mobile application, which is the one you installed earlier. This one is being configured with this touch button. So one click turns you from one sensor to the other. This is a Sigfox-based innovation kit. So it works with Sigfox network. This one is using Bluetooth, Wi-Fi, 3G. This is another commercial device with multiple sensors that comes from a company called Simple Hardware. It's a European, from a Czech Republic. And it has 7 different sensors. This is a commercial device, so you can put it in the outside, in the outdoor version. This innovation kit is targeting guys who will use LoRaWAN network. Once you played with the innovation kits and built your own idea and application, you need to take the application to the next level, which is the commercial version of the application. So you don't work with innovation kits anymore, you work with commercial devices. So if you were trying to build a parking management application using the proximity sensors in this IoTech, now you turn to use the actual parking sensors that are built for commercial use. These are outdoor versions of these devices. So this is a very specific device that is working as a parking sensor, and it only has a magnetic or proximity sensor inside it. So it's one function, but it is made for commercial use for the outdoor environment. The same goes for all of these devices. These are commercial temperature humidity sensors, Bluetooth access cards, accelerometers. This one is for irrigation management. This one is for waste management. So it measures the waste bin fill level. These are photos from the drawers of the lab. So as you said, we have multiple type of devices and gateways, but for every device we have number of devices that can serve up to 15 concurrent students at the same time. So we have number of IoTechs, we have number of sensor set. With the commercial versions, we also, for the commercial devices, we have a limited number of those devices because the students usually wouldn't be playing with these commercial devices. So we have 3 to 5 of every one of those devices. Utility meters, these utility meters are using Sigfox. Network measurement tools, so this tool measures the quality of the network in this specific location, so they can also learn how to measure the quality of the network that will be used in the transmission. So this device measures how good is the Sigfox network in the place. If you're sitting in a country where you don't have a Sigfox network, how to run a small network within the lab environment, this is what is called Sigfox SDR. It is used for device makers to simulate the Sigfox network, but we bring it here to simulate the Sigfox network inside the lab. In countries in the Middle East, for example, in Egypt, we don't have Sigfox, is not permitted yet to work here. So you can use all Sigfox devices through this small Sigfox network within 10 meters inside the lab. The same goes for Bluetooth beacons, LoRaWAN gateways, and so on. Yeah, these are all Bluetooth types of devices, accelerometers, Bluetooth access cards, Bluetooth beacons, different types of beacons, light intensity sensors. If you noticed as well, we're using the IoT here to control the lighting in the lab itself. So we turn on and off the light in the lab. We turn on the light in the outside pools in the street installed beside the lab through this IoT as well. This is the lab in a smart village. It can accommodate up to 15 users. It also comes with this small city maquette where you have street lighting, parking, waste, tank, water tank levels, train controllers. This is the smart city maquette itself. The full city is controlled by 2 IoTechs who are installed inside the maquette. So we tell them how to use this, how to build this maquette by yourself. This is a web interface that gives you the status of the city. Usually in a professional environment, this is called City Operations Center. So this is a very small, tiny version of a City Operations Center that is provided for the students to learn. And it is provided with its source code, with a curriculum, how to build this. You can also have a look on the lab itself through a video tour available over this Facebook page. So you can go to facebook.com/Egypt IoT Lab, and you will have access to a video tour inside the lab and its devices. At a point of time, we also considered a very small maquette for every student, so they don't all jump in on the smart city maquette with the instructor, but they can have their own small city maquette here. It comes with actuators for lighting, and these lighting are actually controlled by the IoT device. It has an area to put the parking sensor used with the IoT as well. The door sensors that comes with the IoT as well. So this maquette is managed and controlled by an IoT. It is a very small, tiny piece of wood that the students can do on his own table instead of standing on top of the big one with the instructor. Okay, so now let's go for level 3 of the lab. Level 3 of the labs are very specific labs who has version level 1 and level 2 of the labs, but this one is very much focused on self-driving technologies. And this one is provided with 2 low-speed self-driving vehicles. These are actually golf cars. So it is 2 golf cars that has been modified to become self-driving. And usually those are in the surrounding around the lab. They go around the lab itself, and it is controlled from the environment inside the lab. So here we teach the students about the type of sensors and actuators that are inside the self-driving cars. We give them information about the technology used inside the self-driving, how to monitor the status of the car itself through an onboard device. So we have here an Android tablet that provides you with information about the status of the car. We have also mobile applications that reflect the status of the car, and web interface that is supposed to allow you to manage a fleet of these cars. Where they are now, how much battery do they have in each car, what is the destination for the car, how many hours it has been used. Lots of sensors about in each of those cars are actually reflected on this web interface. A live demo also for this, for the very first version of this car is also available in this YouTube link. Having this car, you can take the students to a totally different level of very professional level of applications development for self-driving. You can also use it for mechatronic engineering tutorials and teaching, but this is totally outside the scope of the software developers, but you can also reuse the lab for the same thing. This is a mobile application that gives you information about the status of the car. It comes with tutorials how to develop the application, how to read the information from a remote car, what is the communication type of communication. Here we are very much focused on MQTT protocol, which you should have learned in the first level or the second level, and now you're applying it for remote management of the car. If you'd like to drive it remotely, or you will allow it to be self-driving from destination X to destination Y. You monitor the status of every sensor in the car, as we said, battery level, speed, object detection information, and so on. You can see all the error logs, so you can see the error logs inside the car itself, how the computers inside the car is operating and reporting any errors here. This is available in bilingual English and Arabic for sure. Having these levels of the lab, depending on the level you have the online courses, but you can run also class-based curriculum, and the class-based is actually a set of courses depending on the level of the lab you have. So if you have the mobile version of the lab, which is only the IoT kit with the phone, you can run this set of courses on a class-based, so you can have your students interacting with you over 12 days, so they learn it from up to those 12 days, 2 days for the IoT value chain, 5 days for the application development on top of the platform, 5 days for the lab hands-on devices on each device on the lab. If you go for a little bit advanced level, you can also have here, allow them to develop their own custom plugins in the data visualization, their own custom back-end events in the platform. So the platform itself allows you to develop your own custom visualization, data visualization plugin, not just the ones provided with the platform, your own back-end monitored events and custom events. If you go for the expert lab, you have prototyping boards, Raspberry Pis and Arduinos, where you can use them as well to give introduction about embedded systems, utilizing these prototyping boards, Arduino and Raspberry Pis over 10 days, trying to develop a new device. Also, these are 10 days. This is pure software development. This is embedded systems development training. And the most advanced one, which is for the self-driving, you can have the overview and the basics over 5 and 10 days, but you can extend this to be 3 months of self-driving technology development. The total sum of this can reach up to 70 days. That's what we call a diploma. So you can have your own diploma out of this lab. This is how the Ministry of Communication and Information Technology is using these labs inside Information Technology Institute as a postgraduate studies. So you can have 3 months diploma or a complete 9 months postgraduate diploma study. where are these trainings have been provided? It has been for sure in Egypt, but we also delivered it in Saudi Arabia. We delivered it in Kuwait. We delivered it in South Africa. Because this lab is promoted and sponsored by the Minister of Communication and Information Technology. So all the ministers that comes to visit our minister, they usually have a tour in the lab. They like the idea. They like how to build the future jobs for the youth. So they usually ask for help to redundant the lab in their countries. Now we're working with our Saudi colleagues to build labs, similar labs in Saudi Arabia. The mobile lab, which is just a mobile application with the IoT kit, the instructor can take it in a small bag and travel with it, delivers the training anywhere in any governorate. So we did that in UAE, we did that in South Africa. Yeah, we did it in many locations. So this is a Johannesburg and South Africa training as well. This was a full day training during Cairo telecom event. Out of this, we're working now on a certification program for the trainers, because these labs are expanding. We're not anymore able to deliver the trainings all over these labs. So we're building a certification program for trainers. So from those who took the diploma of the lab, we select the proper ones that can work as a trainer and help us being a trainer remotely somewhere else. So we take graduates out of the diploma. We pick some of them who has the capabilities to become a trainer, and we certify them being a trainer, and then they can deliver the training later on. Thank you. I hope you enjoyed the session as much as possible. I tried to be as quick as possible. I know it's end of the day. It has been full days of lots of sessions, and by this time you must be very tired, falling asleep. But
don't be scared to the questions.
yeah, I would love to have. Thank you. Thanks a lot. Thank you.
I don't know. I don't want to be impolite, but can you share the slides?
Sure.
So please, because I see a lot of similarities in what I am doing.
Great.
So if I want to set up such a lab, how much money will cost?
Yeah, it depends on the level. So if you go for
level, because I'm involved in autonomous driving.
Okay, so if you take the full scope, the last level, this is around 6 million Egyptian pound. This is almost
6 million divided by 20.
Yes. Yeah.
150.
Yes.
Okay.
Yeah.
Very cheap. Yeah, I think it's cheap.
It is because it comes with all these devices, with the curriculum, with the online courses, so and the trainer for the first batch of trainers.
I want to integrate it in the curriculum, in the academic education, so to speak.
Yeah.
Like support for applications.
Okay, that's the way. Maybe I mentioned this during the slides. We have 10 IoT labs. 6 of them are inside Information Technology Institute, which is a postgraduate studies for information technology. But 4 of the labs, which is 4 out of the 10, is actually in the academic colleges for computer engineering and computer communication. So these labs are hosted inside the university. We provided the curriculum. We train the trainers. So we train the staff of the university on the lab, and they now are merging this into their own curriculum because they have built the curriculum themselves and they know where to put the right lecture, the right topic after which lecture.
But what about we have started with this kind of stuff and we create virtual, let's say, filling stations.
Okay.
We create virtual smart rooms with all the equipment there virtually, and we model the behavior, and the students has to develop the control.
Yeah.
Yeah. Then can be that an alternative, or I can combine the virtual with the real one, and then I have.
Yeah, I see it combined. We have thought about the virtualization part, especially during Corona time, where people are not allowed to come to the lab. How to take the lab to the outside world, out of the room. No, but it was, I would say, through some gaming development environment. But we didn't really continue with that because we started to see that, okay, Corona is going out. We will not live into this forever. So, okay, let's focus again. But it is very much doable as well.
I see a tendency to this digital twin approach where you have a physical
for digital twin, for sure.
And the virtual and put them together. I think it's a very nice platform.
Sure. Yeah, the idea is very good as well to have it.
I don't know if you want to collaborate, but I have a lot of students graduating with me, and I push them in this direction. So what I was doing now, I was at the conference, one of my colleagues.
Maybe we go back here.
Austrian, someone from Austria, from Linz University, and they built already, they have the sensory for a smart room.
Okay.
And we did the virtual one already. So now we are merging the stuff remotely.
Yeah, why not?
If you, by example, if you are interested in developing the virtual parts, we have a lot of experience with that one. And it could be very nice seminars remotely.
Yeah.
So you have already this lab that you can hire, and you provide only the virtual setup.
We can even, look at the funding side of the H2020 and tutorial funding. So we have funding activities that can fund this type of collaboration to develop this type of digital twin solutions.
That will be because we built this kind of
use cases. Yeah.
Already with
Good.
Elevators, I told you.
Yeah.
Inside,
Perfect.
Inside, they were from the architecture faculty, so they were very good in building this.
Yeah, we got lots of requests from the architecture guys as well. They want to jump into this smart city as redesign the city, okay? But we're very much focused on the software. So
exactly, it's a small one.
Yeah.
But it has a lot of application for, at least for the academia.
Sure.
To develop different algorithms for energy consumption, for, I don't know.
Lots of ideas in academia, and we also welcome the cooperation with academia through the academia funding type of collaborations. H2020 projects, Prima funding. We have a program here between Egypt and Spain to fund collaboration between Egyptian and Spanish companies.
We started already to look for 5 minutes.
تمام احنا we already finished. We're taking the questions, so we might have few questions from the online guys if there's a way to take the questions from the online. We already finished the session, so we're taking the questions and answers now.
Thank you so much.
Thank you. It was broadcasted online as well.
So I think I love the idea.
Thank you.
Because it's a need in academia to have practice.
Yeah, it is a link between the practical world and the academic world.
The students are becoming very enthusiastic.
Yeah, because they can play with things now, not just.
The limit.
Yeah.
Give them stuff to play.
Yeah, true.
I think
Universities and مظبوط.
Yeah. So I think you have my email. So please contact me and see what we can arrange.
Great.
Because I think we are looking in the same direction.
Yeah. The good thing here is that we're trying to wear two hats: the academic hat inside the universities, and getting also students ready for the outside jobs, the practical things in the cities. So that's the bridge. So we bring the technology from outside of the university to the university, and we take the people from the university to the outside world.
I think the best part is that in the academia you can develop nice applications that can be run on the on this
Sure,
kind of platform.
creating a new use cases
Yes, because-
out of this puzzle. So you have a puzzle now, you can build something new out of this.
But you cannot imagine that I already defined project for autonomously parking with a car.
Okay,
So we have, for example, projects for night vision also for the car with a lot of sensory. We are doing parking and driving autonomously in a distribution center which is scaled, but we have also the virtual part. So we have
Okay.
a lot of sensory. So I recognize a lot of applications, and so also here,
Sure.
so they are coming naturally.
very much linked.
Yeah, yeah.
Yeah.
I think it's nice now with a lot of sensory actuators.
Yeah, having the physical things, it's not just about the imagination, but now you can see it, you can feel it. So it becomes much more, if it's all about the imagination and visualization, people get quickly fed up out of maybe 10 sessions or whatsoever. They feel that, okay, it's not a live thing, we're just simulating. But once they see the devices, they don't want to go outside the lab. You actually kick them out of the lab by the end of the training. So now you're ready, go out. So
ممكن واحد من البيت يستخدم مهارة تك والحاجات دي واستخدام الموبايل ويعمل
أيوة.
IoT device
مظبوط.
لغاية البروفيشنال اللي حضرتك قلت عليه 70.
لغايه الليفل الاولاني هم دول 3 levels. Those are 3 levels. From home you can do level 1, and we have now some courses that is being prepared for Maharatech to link between level 1 and level 2, so you don't come and see the device first time in the lab. You can see it at home. You can get familiar with the device through some videos. So once you get in the lab, you fully utilize your time in the lab, because the labs are limited and you need to serve many people. Inside ITI, inside
النص التاني ممكن من البيت
مظبوط
بعد كده لازم براكتيكال
مظبوط. It's all about getting your hands dirty on the devices.
من النص التاني يبقى في كورس
لا. For undergraduate students, these courses are provided for free by Ministry of Communication during summer vacations, during mid-year vacations. And for after graduation, for the postgraduate studies, the 3 months diploma and the 9 months diploma is also provided for free. Actually, you get an incentive to be dedicated for the 3 months diploma. By the end of the diploma, you get money reward. For the 9 months diploma, you get a monthly incentive to dedicate your time for the 9 months diploma. And even with doing so, for the companies, if a company wants to utilize the lab, they pay for it. But if it's a student, it's for free, as long as you're enrolled in one of those diplomas. And if you're a student and you're not enrolled in any of those diplomas, you pay a very small fee just to know who's taking what. You can imagine if you go and rent a ping pong table, you pay per hour. The same value you pay for a ping pong table, you pay it for one of the sensors here. So you can pay 20 Egyptian pounds, which is $1 per hour, to get any of those devices. The gateways, we multiplied by 5 because the gateways are very limited and they are very expensive as well. So you pay what is equivalent to, per hour. Yeah.
I think it's good.
We have tried it. First lab was 3 years now. We took 1 year to prepare for it, and
No, it's not so easy.
it's really complex.
I've worked with domotica, home automation.
Yeah.
So I see the same concepts, but they are now more powerful because you have different devices that you combine.
Yeah, it's a mix of devices, mix of technologies.
Robotica was a mix of,
Yeah.
one of the, the major players. They provide everything.
Yeah,
But now here you have the diversity and you can combine and do your own applications.
yeah, that's the beauty about it. We mix different types of wireless technologies, different types of devices, different types of innovation kits, different types of commercial devices. So you can now think of whatever. It should be a big puzzle for you to play and bring something out of it. Yeah.
Please, if you can send me the presentation, then I can discuss with
Sure.
my colleagues.
It's difficult to send the presentation.
It's not difficult. This is meant to be for information sharing. This is our marketing material for cooperation with everyone else. So we take. Yes, sure, sure.
Thank you very much.
Thank you.
I like it.
Always welcome. Thanks a lot.